system design is no longer something that one person does on a team. It's a team sport. Everybody has to be involved in system design.
You've said several times that the system design is not diagramming, and I pretty much agree. But can you elaborate on this? What is system design?
I don't think in the near future AI is going to take over the system design job. You, as a system designer, have an assistant to help you out with things.
So, hello everyone, welcome back to the Architecture Weekly YouTube channel. Today I'm talking with Tom, who is a co-founder and CTO at Multiplayer app. Hello, Tom.
Hi, nice to see you.
Yeah, nice to see you too. So tell us please a little bit about yourself and what you do at Multiplayer.
Sure. So I am co-founder and CTO of Multiplayer. Multiplayer is a software company that helps teams deliver and work on distributed systems. My background is in software development for about 30 years. I got my start in speech recognition and robotics and working in real-time systems, segued into telecom software, building large distributed systems. And as the web became a thing, moved on to the internet, doing the same kind of thing. So I've focused a lot on back-end systems for most of my career, working with large companies and small, and that brings us to today.
I think that right now, the current AI tools are already pretty powerful. So if you ask like ChatGPT to help you design something, given the requirements, it will be pretty decent in terms of writing an RFC for you, or drafting a sequence diagram, how the things can work, or designing some components that would fulfill your task. How do you see the AI tools right now applied in the system design? Like, do you see any trends that people are using, like what developers are doing with AI applied to system design?
Well, I think we're at the very beginning of applying AI to system design. I agree with you. You can use, ChatGPT and other tools to help you with a requirements doc, maybe even to help you in general suggest a design for an application that you want to build. Say you want to design an e-commerce app. A large language model might be able to suggest the common components that you might want in a system design for that purpose. It's descriptive, it's language. You still have to do the things, you have to translate that into a working system. There's a big leap there, So I think what's going to happen is this technology is going to be used to actually create the systems and not just give you advice on how to do it. And you can think of that as an evolution of the current tools like Copilot, which help you on a source code level. Today you can use tools to help you write some functions or solve some problems in source. And it's only a matter of time before that starts going further up. And I think system design is really right for that application. Challenges are, there's a data problem here. Okay. You've got a lot of text about system design, but you don't have the data required to turn that into a working system easily. You've got a number of tools. This is a challenge with system design in general. A system design is no longer something that one person does on a team. It's a team sport. Everybody has to be involved in system design. You've got DevOps, QA, developers, front end, back end. You even have business people who are driving the requirements and more involved in the end system that's being developed to make sure that it's meeting the requirements and functionality. That there are a lot of components that need to come together to take the language of the request to working functional products. There's a sort of gap there. It's something I'm really interested in working on. I'm sure others are too, but it's to not just output text that needs to be translated into lots of code, but to actually create the components themselves. And there's tooling there, which we're trying to work on now.
Okay, so the big problem for me right now, the challenge that I see is that you can draw fancy diagrams, right, and explain how it's going to happen, but actually then you have the whole company and its own tools and the infrastructure patterns and policies that you need to take into account to actually create those in the production environment. So do you think that AI tools will be able to, like, given they are augmented on the company level, will be able to like start generating these things like Terraform templates and I don't know, like everything else, like services definitions, pull requests with the appropriate stuff?
I do, and you touched on something that's really important, which is system design is not diagramming. Creating a diagram or
Of
creating
course.
some text is not really system design. Visualization is important, but visualization without connectivity to a system is kind of, I don't want to say pointless. It helps with the communication, but it's the trap that we're in now with system design, which is a lot of manual work trying to keep pictures up to date with a running system. There's a gap there. Again, we're trying to solve this, but it really needs better tooling. You need to be able to connect the request, the language request for something with data, a tool that is able to take those specifications and turn it into something real. It might be Terraform at the lowest end, or Bloomy or something. Maybe it's bringing together pre-built services, a Redis cluster for this or a database for that. Generating code surely is part of that. I think that AI models work best when a large problem is split up into smaller ones. So to say, hey, build me a system with all the code of Terraform and all of these services that implement these API methods in one prompt, I don't know that if that's impossible. It's definitely impossible now. Who knows about the future? But I would think that like if you're trying to solve a problem yourself as a developer, you take the large problem, split it up into smaller problems, and go after each one of those. That's what's necessary to make this a reality. Also, building a system is something you just don't do by yourself. It is really a collaborative effort. So to incorporate tooling that allows a team together to work on stuff is an important piece of making AI effective at the system design level.
A couple of days ago, I saw a tweet talking about that the developer's work will be transformed in a way that you're not writing code anymore, but you're writing the prompts so that the AI can generate the code. So you're more like an architect at a software at a class level, let's say, or module level, rather than typing this code manually. What you told just now is reminding me about the same analogy. So like you can do the design, but you do that instead of drawing the rectangles. You're like, first of all, using the AI to facilitate the decision making, like, hey, given those requirements, please help me build the system. And then you can guide the AI to actually step by step implementing those stuff with like Terraform templates and then module definitions and then some code and so on and so on. It also reminds me about like using the AI for writing articles or guides or like internal documentation, where again, as you said, instead of like write me an article about this, what you would do, like, I want to write an article about, I don't know, like mobile security. Give me an overview of this article. It will give you the bullet points there. And then you can go step by step, like, hey, let's work on the content for number one, for number two, and so on. So do you think the application and system design will be doing the same? Like, hey, generate me the context diagram, and then get me a container diagram for this component, and so on and so on.
Yeah, I do. I envision it a little different. And again, like, diagramming is not kind of system design. The AI system is really an assistant, okay, that you are asking to do maybe some grunt work. I mean, I think AI systems are best at grunt work and being told specific tasks, getting results, and then you give feedback. So you're in the loop. There's a human in the loop. So, and that means you really do have to know system design and a lot of the details about what is generated in order to guide the system, the AI, effectively. So I don't think that in the near future, AI is going to take over the system design job. You, as a system designer, have an assistant to help you out with things. And I also think that these AI tools help level up, young developers, new developers, junior developers, by giving some feedback too. So I think, first of all, everybody should know about system design. Modern software is all about assembling components wiring them together, seeing patterns, and and doing it over and over and over again. So there are a number of things that at play here. So one thing is like all developers should, if you're not, yet introduced to system design, regardless of what you do, you should be learning more about it.
You've said several times that the system design is not diagramming, and I pretty much agree. But can you elaborate on this? What is system design?
Well, I think system design is the process of solving problems with software that involves more than just one simple component. And when I started out, most software was just like desktop software. You installed software on a computer. It didn't talk to anything else. You ran it, you got some value out of it, and then you moved on to a different piece of software and want to do something else. These days you've got mobile apps, web apps. Every internet app is distributed. You've got probably a database in the back end. You probably have some microservices or some services. You probably have pulled in a SaaS provider or two to do authentication or something like that. Software is distributed, and because of that, it's a system. And in order to write any software that's meaningful, you need to know designing those systems. But life is like the world of software development today is all about multiple components of software talking to each other through APIs and assembling software more than writing everything in-house.
Do you want to know how to design proper software systems? Do you want to grow to a senior or staff engineer positions? I developed a business-oriented system design course specifically to achieve those goals. We're gonna learn how to identify and gather the requirements and also prioritize them, how to address performance, security, reliability requirements, how to document software architectures, and how to make architecture decisions. The course consists of 10 lectures, 10 home tasks, and the final work. You're gonna receive the graduation certificates by the end of the course. All the details by the links below the video.
Well, right now, to the definition that you gave, it sounds like the system design is about like building the Lego building blocks. You have a database,
Absolutely.
a cache, a service, and the web app, and you just combine them all together. Do you think that's realistic?
I think, sure. I think that, there's a lot of software you write yourself. If you're not just assembling something purely from pre-built.
But you can do this as well, right? Right now, the maturity of the components is so high that basically you can pick up a lot of serverless solutions, right?
Yeah,
the
sure.
database, the cache, the runtime, and the last thing that you need to do is write 20 lines of code that will just wire it all up together.
Yeah, okay, maybe a little bit more than 20 lines code, but you're right. I totally agree with you. It's more about composing platforms than writing everything from scratch.
Yeah.
And frankly, the older as I get as a developer, the more I want to compose. I don't want to write more. I'd rather rely on great open source or other software that does a particular feature that I need, and I don't have to. That just makes me go faster. Yeah. So systems design is a lot about that, knowing the patterns, seeing the patterns over and over, knowing what's available, and also collaborating with people. The other piece that I think it doesn't get talked about a lot is how much of it is a team sport. Unless you're an entrepreneur just getting an idea off the ground and you only have one person. Most companies, it's all a collaborative effort, and and things are getting more complicated. You've got your DevOps tools, infrastructure as code. You've got maybe microservices architect. People focus on back-end work, different API types, gRPC, RESTful APIs, message queues. Front-end people tend to, focus on the front-end thing, but they consume all of this stuff that back-end developers are doing. So it really is, everybody has to work together. That's very different than not so long ago.
Speaking about components, you mentioned that it's not picking up a single component, but rather a combination of some. I would argue still that in order to make this decision, if you need a single component, several ones, you need some skills like before that. And the skills
Sure.
that you need is about requirements and about weighing the different options to solve the problem, given those requirements, and prioritizing those
Yes.
requirements, and then making the conclusions. And probably, like imagine you're building, I don't know, like a simple video editor. It will be a software deployed to a computer. Like you don't need a connectivity, you don't need a server, like microservices and the backend, no databases, don't need it as well. So
I think I agree with you. There's sure, desktop software is still a thing and doesn't, require talking to a backend. It's rarer though. It used to be all of software was like that. Then you had simple client server, applications where the client, the application, talked directly to a database, and then things started, getting more complex from there. And whether you call them services or microservices, I don't care. Functions, you have software that provides an API that others software consumes. And life as a software developer has become more complicated over the years. It's become easier in some ways, hard in other ways. I mean, to try to, 20 years ago, before say Kubernetes was around, or other tools, or even like Docker, to be able, you had to worry about, how do I build this thing, produce an executable, run it? How do I run it? How do I orchestrate that? Pull, shut down things, bring up new software. It was all custom, and so to luckily there are projects that help out with those tasks of just getting a distributed system up and running. You've got container images now, which makes it so much easier to like deploy things regardless of the language, regardless of how something is built. You've got orchestration tools like Kubernetes, which makes it easier to have a cluster and to bring things up and down, to deploy new software versions. You've got Terraform and others for the infrastructure as code, so you don't have to manually go through and sort of provision things and change things. All great. If if you're a software developer starting out now, there's so much to learn just to get like a hello world application up and running. And let's be honest, they're probably creating a web app or a mobile app, and are quick to discover that, that just doesn't live on its own. It needs to talk to other things to, usually to be interesting.
Yeah, but the modern trend, at least what I see, is that let's go backwards in time. Like PHP was fine in the first place, right? Like you can have a single file having the backend logic and the web in its own. Like React is talking server-side components. This is like, okay, this is what we do, what we did 20 years
that's
ago.
Fine. Yeah, static sites. Yeah, sure.
Exactly. So, I mean, of course, the complexity increases, but the technological solutions catch up as well. Like, because, okay, we have challenges with microservices and deployments and so on. But then Kubernetes comes into place with the containers and the orchestration mechanism and auto-scaling and so on and so on. So we're playing catch up. And for me, right now, the question is not like how much you need to know, because like from one perspective, it increases all the time. But at the same time, you can keep up the average volume of what you need to master at a point of time to be a successful developer. So like it's still pretty much the same, because the mental capacity is like as big as it is. Okay, so right now probably you don't need to know the nuances of like hypervisors, right? But right now you need to understand how Kubernetes API works. So it's like it's shifted, like it went above the appropriate things. So we're not writing assembler anymore, right? So it's like JavaScript on the backend. Goddamn.
Well, let's extend that trend. So where I think things are going is you're soon not going to be thinking about infrastructure. You're not going to be thinking about virtual machines at all. You're not going to be. You're just going to be designing software at a high level. Starting with your system design, system architecture. I've got a web app, talks to an API, microservice or whatever. Fine if you want a monolith, that sort of thing. That might talk to a data service and a database, and here's the schema, and I'm going to just compose it from other things and click to deploy. and I want deployment to happen on Kubernetes, on AWS in production, or I want it to be on Fargate for staging, or I want it Docker Compose for development. And this is where AI comes back into play. Not just AI though, but a lot of this code can be manually done, which is even better. Reduce the risk of hallucination. And anytime AI is generating code for you, you have to look at it. You can't just trust it. It's not at the point yet, maybe won't be for a long time, that you can just trust what is generated. So that's why I think of it as like an assistant for you. You have to be an expert in that, or you have to be somewhat versed in the thing that it's generating to be able to be an editor of what is generated. But I think trends are, you're going up. The logical platform architecture is as high up as you can get, really. And I think AI is going to help connect that further up to from the requirements and patterns to the recommendation of the system design architecture. And whether it's, analyzing something that exists, suggesting something that's new for the new project that you have, or analyzing other things like, security issues or improvements, like helping you iterate. I think AI is going to be involved in that, but you're going to need to know about system design to be that editor. You'll probably also generate code too. You should be a coder too if you are an entrepreneur and you want to get a full system up and running by yourself. But I think there's a lot of exciting things happening with system design and AI.
Yeah, I agree with the statement that the things are going up. And like several years ago, we had to deploy everything manually and upload the changes to virtual machines, right? And now it's gone. Nobody is doing this. Well, right. I know a couple of guys.
Yeah, sure. There's always some.
Yeah. But yeah, I agree. Right now, like literally what I did several weeks ago, I needed some example for my learning course, and I just used the ChatGPT to generate the Terraform example. Like it required some debugging still.
Sure.
It didn't require me to know the Terraform syntax very well. However, it required me to understand the system that I want to get in the result. And it was like very simple. It was several virtual machines deployed across 2 regions with load balancers and so on. So that was an availability exercise. But still, I precisely knew what I had to get in the end. And then I could double check because I had to go through several iterations to get ChatGPT to generate exactly what I had to do. And then fix the Terraform because it had some syntax issues. But in the end, I managed to deploy it, so to check that, I got exactly what I wanted to get. So and probably I like this idea that in future we will be doing less things manually and more automated, and like the whole deployment things, you would be able to just click it from the like template builder or system builder, and then transparently say, right now I want this in US East 1, right? Like just go.
Yeah, I agree with you. I think that's where it's going. Honestly, I don't want to, I can hack around Terraform. I don't want to be an expert at some of this stuff. I'd rather be able to communicate my requirements and have something not just generated, because if it's generated, like you said, you have to review it. You have to like check it. You have to kind of be I don't want to say an expert, but you have to know something about the thing being generated. I think that as you go further up, the stuff that will be generated will be less about the very low level things. Maybe if you think about composing platforms, I mean, there's a lot that could be done today with, using container technologies and best practices for implementations of certain patterns like Redis clusters and other things that could just be coded up and solid and working, and that is just incorporated into a platform, and where things sort of are wired up together for you in a reliable way, and that skips the need for the person developing the system to be an expert in all the things that are wired up. You're just thinking about system design. I'm composing with the software.
Yeah, but the question is like, what level of abstraction you need to be an expert of?
Sure. Yeah, and I would say that, I think eventually it will be, well, you should know, everybody should know at least one language. If you have to, create a service that does the special sauce of your system, you've got to be able to do. You have to have a team that is able to do that. But I think, personally, I think it's going further up, so that system design is a key place that is likely not, you not going to get replaced, because it's so connected to the requirements for an application. It's like requirements and system design kind of go hand in hand. And then when you get to implementation, that's when you get to coding. A lot of that is going to go away, I think.
Okay, so yeah, I agree a lot that requirements are the key. So once you understand what components fit the particular requirement or can fulfill it, right, then you just go and use it, and that's it. And the amount of code that we're gonna write will be decreasing. In the more general your software become, the less code you will be writing, right? And only
Yes.
in some specialized things, like new like medical stuff or like new physics stuff, then you will be writing a lot of code, but not in the e-commerce, right? So
Right.
e-commerce is figured to a certain extent.
Yeah, there are only so many ways you can code up an e-commerce site. That's not. There's certain problems that I don't know, that are solved. You're tweaking things like your schemas and your things, things maybe that you're selling, and I don't know. But a lot of applications, standard applications, have best practices and certain patterns. That's perfect for AI to help with. It'll help somebody who might not know about these things get something up and running quickly. The entrepreneur or the new developer or the business person who might not have any coding experience but knows what they want. I think AI will help, all of these people. And, and frankly, as a senior developer, there are things that I just don't want to write anymore. I think about, in my career, how many times I've written an authentication service. I know there's SaaS products that are out there, but I might not necessarily be able to, for a project, be able to use those, or they might be too expensive or not the right pricing model. There are lots of times you have to do something inside your own platform. But I'd love for, AI to suggest patterns, and also those patterns be connected to real software that could be put into a platform and deployed as part of tooling, as part of a tool, and doesn't require me to analyze every low level thing to make sure it's not hallucinated something strange.
Yeah, exactly. All the problem is that you cannot use the same AI tool or like in general to double check its work, because the tests you're gonna generate are testing the implementation, and you don't need that. You need to test the requirements. So it's like a little bit challenging, but otherwise that's good news. Otherwise, what would we do, right? If we yeah. Okay. What do you think are the best applications of AI in system design right now? Like what the developers should be learning who wants to thrive in system design like today?
So, so just thrive in system design. Well, right now it requires a lot of, learning. Okay, seeing patterns, learning beyond maybe where you're working at. And there's a lot of great content, podcasts to, to learn about real systems that you might not be working on in the moment. I think that is such a great thing. I love the content that's on YouTube and other places that describe real world experience, scaling systems, when to use certain technologies versus others, pros and cons of different approaches. I love the war stories of like when something didn't work or broke, under what conditions. I think that, developers are still left having to learn about system design in those ways, because I'm sure you can interact with ChatGPT and have a conversation. It could suggest some interesting things, but there is, it still does hallucinate. It does come up with some wacky ideas today, because there's a lack of it. The problem is like the data that's there isn't so great right now, and that is a problem that will get solved. But it's just not there. So to learn about system design, you really have to do it yourself. And I think over time, AI models, and we're working on this, we'll have great data sets and a connection with not just writing about the system design where I have to read it, really understand it, and then make the leap of implementation, but it can, be connected to, a platform that can, where you can try things out easily. So we're in the early days right now, I would say. I would say we're in the early days of AI connected to systems design. It's got great promise. There's a lot of work happening. First on the data side, collecting the right amount of data, and then the tooling side to do something with it other than just describe systems. That's happening today. I'm really excited about that. So in the near future, there will be new ways of learning about system design, interacting, trying ideas. I mean, I've always wanted to be able to, have a tool that lets me compose a platform, and now with chat, be able to describe a platform, have a system architecture in front of me that's more than just boxes and lines, but something that is describing a real system that I can click to deploy, to try out ideas, and not just learn, not just read about something or listen about something, but to have something tangible I can work with. And that problem is being solved.
Okay, that's an interesting promise, and really looking forward to it. So what do you do now? Like what Multiplayer is about?
So, through Multiplayer, I started Multiplayer because I experienced a number of challenges working on distributed systems. It starts with knowing what your software is if you have a complex platform, and you might be surprised that lots of companies don't understand all of the components in their system, don't have a good way to visualize it, don't have a good way to understand all of the dependencies. So there's a lot of sort of coding against this sort of black box, which can cause some problems. There's a lot of communication issues. And so what we've tried to do is essentially build this tool. Think of it as kind of like Figma for the back end, where you have a great visualization, top-down view of your system architecture, dependencies, APIs, flows, but you're able to work on it, design new features, understand the relationships between things so you don't break stuff. Also, we have this feature called Radar, which helps auto-document using your system as the source of truth. So it takes the manual work out of documentation. So if you've ever sort of tried to put together a system architecture in Visio or a diagramming tool, you know how that can be inaccurate once you're done and sort of drift over time. So we've solved that problem. We also have a platform debugger, which makes it super easy to debug problems and have all the information from front end deep into your back end as you're working with front end or back end on fixing a bug. So that's a quick snapshot.
All right. So I mean, the problem of understanding the landscape of the distributed system is pretty typical. However, what bothers me right now is that the majority of the systems are built on top of the infrastructure as code, which is kind of very, very easy to reason about, right? And there are tons of visualization tools that help you build this understanding right away. How's your tool is actually what's the problem still there that a separate tool is required?
Yeah, so infrastructure as code is great when you're thinking about infrastructure, but it doesn't give you the software side of things, like your apps, your microservices, your third-party dependencies, and what is actually used. Infrastructure as code lets you to kind of spin up and provision things, but it doesn't give you visibility into your APIs. It doesn't give you visibility into what's actually being used by your software. And also it's not helping you debug things. So there's a lot of manual work, still involved, and the tools that help you visualize your infrastructure, they're great, but we're essentially taking a top-down approach. I think, I sort of describe it, if you were to start a new job and, first day on the job, you'd want to know, what is your software? And what we provide is that visualization from top down that maybe the person who knows all of the things would draw on a whiteboard, okay? And they describe all of the components and what talks to what, and then drill down into the specifics. But that's kind of 10,000 foot view of what we're trying to do.
Okay, so basically, if we imagine the onboarding process, then you would go there, ask a software engineer, and asking like, hey, what components do you have? What are the client-facing things? Where the database allocate? Okay, how do you do that? Like, do you need an agent installed somewhere, or like, how it happens?
Yeah, so today. So there's where we are today. We're a startup. So there's where we are today and where we're going. We are built. The auto documentation piece is built on top of OpenTelemetry, but we have an agentless approach that's in development. Will be out shortly in the fall. And we essentially, are looking at a lot of the same data that your APM tools are provided. Distributed traces, logs, metrics. But we're looking at them in a little different way. We're looking at them from the perspective of auto documentation, tracking, and debugging. So, we're analyzing this information. We're detecting, any services, deep dependencies, flows, and also down to the APIs. So if you have, a lot of companies don't have any API documentation, they just kind of code stuff and later on are asked to sort of develop documentation, and it's kind of tough to do. So we give that full picture without any manual work.
So let me think about it. So you basically rely on the observability information to build the understanding of how the components look like. What kind of diagrams do you build? Is it all the components on a single view, or it's a set of diagrams? How it happens?
So we visualize the logical platform architecture, and we have a number of different views and visualizations. I mean, one thing,
Do you have an example? Like, can you show anything?
Sure. Yeah. I mean, if you'd like me to share my screen, I'm happy to.
Yeah. Why not? I mean that would add the understanding of what happens. You can also drop me the images later, so I can add them.
Okay. Yeah, I could do that, but I guess if you'd like me to do to share this now, let me share my screen. And it's always nice to have a little picture. I'll show.
Of course.
Okay. So 1 second. Let me get. All right. So here's an example platform within Multiplayer. One of our customers who's graciously allowed us to use their platform for demos. We pulled platforms, all the system components, repositories, environments. We also have notebooks and sketches, and Radar is to set up to auto document all of this stuff. So if you take a platform, and all of this is multi-user collaborative, just like Figma. And this is the full platform. We show dependencies, but we also show views. So a lot of times you have a platform that's pretty complex, and you might have 1,000 components. It might not make sense to have an all view. You can show a table view in that case, but you can create these custom views for different subsystems, authentication, search, and other stuff.
Okay. So different views per concern, basically.
Exactly. Plus, we support design branches. So if you're designing a new feature, you can show diffs and changes. So you can easily, for a new design, communicate. So one of the biggest challenges with working on distributed systems is the communication part. Working with your CTO or your peers or your front end, your back end team, your QA, your DevOps, and getting them to understand, for say a new feature that you're developing, what do you intend to change? And diagramming tools, here are examples of the before Multiplayer times where there were the same platform as in a diagramming tool. I mean, this isn't really built for, right?
Yeah.
So, and you go down to the APIs, you have the same problems with all the way down. Okay, so from the top down, I mean, you want to see diffs, you want to see changes, you want to be able to communicate, you want to be able to track automatically, you want to see, that source of truth. What is your system? It's always out of date using manual work and the current tools. And with Radar, we can automatically, discover and track everything from your system architecture, dependencies, flows, which are really awesome if you like sequence diagrams and you want to discover all of the unique transactions that happen. We do that. And we also, once you have this source of truth, do stuff with it. So we've got a great debugger coming out soon. We're really excited about. Makes the manual work of scouring through APM data to get the stuff related to a session that had a problem with your QA or your customer, all that goes away. But we also bring together things like sketches and rich text docs, so you can have just plain old diagrams or sketch ideas and share them, that kind of stuff. And when you're done, say with your design, you can have a design review and request reviews from your peers and others.
Yeah. From what I heard, I don't see any like AI applied, right? That's like the collection of symbols, and then you just visualize it, then you allow to add new components. Basically, that's an editor, and then some processes on top of that. So where is the AI there?
So we have a number of things in development. We've got, once you have your system architecture, documented, you can do some really interesting things with AI. One of the challenges that teams have or companies have is communicating, say, their APIs to others. Maybe their partners are trying to integrate. Usually you share a Swagger link, or maybe you've got some other example code, might not be completely up to date. I think in the future, one of the interesting uses of AI will be have a kind of chat interface with your APIs, so that as a consumer of an API, I could just ask a few questions. How do I do this? Show me some code, try it out. Instead of having to scour through the documentation, figure out, okay, what do I call first and second and third in order to get the information that I need? And APIs are getting more and more complicated. So the challenges of system design and integration are just getting bigger. So I think there are a lot of opportunities for AI to be applied to, system design and development. And that's just one, but you can imagine, and these are some of the things we're working on, but you can imagine architecture, design feedback, if you're looking to solve a problem, to be able to interact with a model that's able to suggest different solutions to a problem, to be able to analyze a current architecture for maybe security issues or optimizations, things.
The example of AI giving you advices on how to use the API, basically, like achieving something with a set of APIs.
I've worked with a lot of developers, especially young developers. My message these days, more and more, is like learn as much as you can about system design. It's all about software talking to software, and it's just going in that direction. There's some really interesting problems that are solved. It's an exciting, field, and it's wise to spend a lot of time, because it's, regardless of what type of development you do, front end, back end, DevOps, my message is system design is a team sport. You have to know it to be successful, I think, as a software developer, and to work with other people and to build a successful product and company, whatever you want to do.
Okay, that sounds very inspirational. Thank you very much. Thank you very much for listening. Leave a like if you like this conversation. Don't forget to subscribe to the channel. Thank you very much.